Lecture 14, Mystery Lights, Marfa, Hessdalen, Brown Mountain. The first ghost shows up exactly where an engineer would put it, 9 miles east of Marfa, Texas, on US 90, at a purpose-built turnout the state erected in 2003 with concrete pads, railings, and an interpretive sign that never quite says, "You are here to look at refraction." The Mitchell Flat lies ahead like a carpenter's level. The Davis and Coyote Ranges bracket the southern horizon. US 67 and the Union Pacific Line stitch Presidio to the rest of America with headlamps and halogens. Then, because desert air is a prankster with a physics degree, something bright blooms out there, above chaparral that has no electrical grid, hovers for a few steady seconds, splits neatly into two, recombines, and slides sideways like a patient ember. Tourists applaud because they can see it without binoculars. A border patrol Tahoe idles as if waiting for a confession. A local in a ranch cap does not stop chewing because the family has been watching versions of this since a cowboy named Robert Ellison said he saw lights in 1883, and because men from Marfa Army Airfield were bored enough in the 1950s and early 1960s to log them when traffic on 67 was thin. Whether you start the written record with Ellison or with the base kids and their clipboards, the three behaviors that survive every retelling are maddeningly specific. The lights appear low over the flats south of the highway rather than over town. They hold station or drift with inhuman patience. They split, merge, dim, and die without throwing the linear glare a headlamp or a diner would. It is exactly the kind of choreography that forces you to measure or become folklore. Follow the longitude northeast into the Blue Ridge, and the mountain that keeps its own weather also keeps its own lights. Brown Mountain, the bald ridge east of Linville Gorge you can see from Lost Cove Cliffs, Wiseman's View, and the Blue Ridge Parkway near milepost 310, has a file that starts with 19th century will-o'-the-wisp talk and turns adult in 1913, when the U.S. Forest Service posted a ranger to watch, and again in 1922, when the U.S. Geological Survey ran a field study instead of a seance. The USGS man, George Mansfield, did not bring incense, he brought maps, a theodolite, and the willingness to be boring. From Linville and the flats near Lenore he synchronized mystery flashes with locomotive headlamps in the Catawba Valley, later with automobile headlights on the Morganton-Lenore roads, and with brush fires in dry spells. Critics pointed to 1916's floods, when some tracks washed out, as proof locomotives were innocent, but Mansfield's wind and inversion model survived because not all lines were out at once, roads had multiplied, and stratified air does not ask a railroad's permission to bend. Light. A century later, Appalachian State physicist Daniel Cottone's automated cameras near Jonah's Ridge dutifully collected aircraft, meteors, and distant headlights dressed in mirage, the kind of result that makes believers sigh and engineers smile. The parkway remains a good date. The valley beneath it is a waveguide. Romance and radiative transfer have shared custody for 100 years. Now swap rhododendron for birch and bog. Hessdalen, a 12-kilometer north-south valley in Hessdalen Municipality, Trøndelag, almost equal to 62.8 degree N, spent the winters of 1981 to 1984 punctuating evenings with lights that ignored forestry schedules. Locals had been muttering about flickers since the 1940s. In the 81 to 84 flap the cadence tightened to weekly and sometimes nightly. Grapefruit, to car-sized white, amber, and red globes hovering a few hundred meters above slopes or running the valley axis at speeds that insulted vocabulary. Then someone did the sensible thing. In 1983, Stfold University's Erling Strand and students turned a snowbound pasture into a laboratory with cameras, binoculars, a theodolite, radar access, and a primitive spectrum analyzer paid for with a lunch budget. The valley obliged, long exposure photos of globes leaving ropes of light, radar returns with cross-sections too big to be clutter, and, on merciful nights, spectra reading like a smooth continuum with bright shoulders, the kind that put sodium's 589 nanometers and oxygen's red features where they belonged. The 1998 Hessdalen Automatic Measurement Station, an all-sky camera, magnetometers, and an honest VLF receiver in a weatherproof box, kept the diary going through quiet years. The later EMBLA campaigns added multicolor spectra and better timing. Norway had, for once, given anomalies a budget. Air has 3 cheap tricks that counterfeit miracles on schedule: temperature inversions, ducting, and your brain. On clear nights the ground loses heat to space. A shallow skin of near-surface air cools and densifies, and a warmer slab sits on top like a lid. Refractive index follows density, so light bends toward the denser layer. Put a headlamp at the right range and elevation and you've built a waveguide. A car cresting a distant grade rises above the horizon, floats, and shivers when an inversion ripples. The brain doesn't have a checkbox for ducted light. It has priors built from kitchen distances and parking lots. At Marfa, a correlation you can do with a notebook, count lights from the viewing area while a friend tallies cars on US 67 with a walkie-talkie, tells an embarrassing truth. The parade thins after midnight when traffic dies, flares on weekends, and obeys the geometry of bends east of the turnout that hold headlamps at a fixed apparent elevation for kilometers. Splitting and merging are often just two vehicles diverging inside a duct. Color shifts are the atmosphere doing its prism impression, favoring longer wavelengths as turbulence and aerosol burden change. You do not have to disrespect a witness to retire a ghost, you only have to know that stratified air enjoys costume parties. Hessdalen refuses to die of headlights because boreal winters will not take automobile for an answer when a light hovers over spruce at 2317 and leaves a spectrum your street doesn't own. On one of the better instrumented nights, a bright white amber target hung for minutes at a fixed altitude above forest, a slit spectrograph lifted a smooth continuum, hot dust or gas, not an LED's blue pump plus phosphor. Binoculars saw a seeing limited oval rather than a filament or mast-mounted point. Call it an air plasma or a hot particle cloud and you inherit the questions adults like, where does the energy come from, what maintains ionization against recombination, why that valley, why that weather. Strand's crew and later teams offered an unsentimental catalogue, dusty. Plasmas energized by local fields, aerosols from old mines and soil, activated by humidity and tiny charge separations, radon-seeded ionization that lowers ignition thresholds, a valley that acts like its own leaky capacitor on dry, cold nights. Days with nothing but stars are not a failure of imagination, they are a denominator. An anomaly means nothing without the many nights it refused to appear. Brown Mountain's inventory falls harder to optics because the Catawba Valley is a light pipeline and the parkway is a theater balcony. The basic fieldcraft that replaces legend with geometry can be carried in a sedan, a hand-bearing compass, a friend in a pickup below, a few texted timestamps. Pick the azimuth where the orbs favor the ridge, mark it, send your friend to a suspected road, have them flash high beams at agreed minutes, watch the hovering light obey the minute hand from a place your map already colored gray. When fogs sit in the gorge and inversions stretch like cellophane, light leaps ridges with no right to, and municipal brush fires turn into stationary glows that aspire to sainthood. The old argument from 1916, the flood cut power, the lights persisted, melts when you read the timetables and add roads. Not all lines were out, lanterns and later gasoline cars kept the valley's sources alive. Inversion physics doesn't care how a photon started life once it arrives at the layer that will bend it. What refuses the stamp, rare, faint, low, with no road to blame, deserves instrumentation, not poetry. There is a right way to make night honest, and the parts cost less than a used base boat. Lock two cameras to GPS-disciplined clocks that agree within a millisecond, mount them a few kilometers apart with clean azimuth references, give each a plate scale so a pixel means a specific arc minute, bolt a slit spectrograph to one mount, add a photodiode sampling at kilohertz for flicker and a pocket weather mask that writes temperature and wind at 1 minute cadence. Triangulation turns, it floated over the ridge, into, it sat 42 kilometers away, 2 meters above a shallow duct. Spectra pick winners. A smooth plankish continuum says hot solids or aerosols, nitrogen bands around 337 and 357 nanometers, plus oxygen's green, 557.7 nanometers, or the sodium doublet at 589 nanometers, point to gas discharges, LEDs tattle with a narrow blue spike riding a lopsided phosphor hump. Old HID headlights publish mercury and sodium lines like an autograph. Tie the frames to a traffic log and you can retire 3/4 of a Friday without breaking a sweat. The residue is where your curiosity earns full pay. Spectroscopy is the anti-poetry that keeps the campfire fun. Headlight rays ducted by a nocturnal inversion trace line-dominated spectra and stick, when triangulated, to a physiological horizon just above a distant ridge. A self-luminous combustion event aloft lifts a warm continuum with molecular shoulders and sometimes an oxygen spike. A dusty plasma flickers in a way filaments and LEDs cannot, with brightness changes faster than thermal inertia would allow. Add a small radar, one of the modern units that tells a bird from a drone, to check for wing beats. Add VLF receivers that hear the atmosphere's low-frequency hiss. Add a magnetometer for local EM tantrums. Then stop flattering your theory and log what happens when the valley's private weather, lapse rates, humidity, shear, turns the knobs. The nights that remain after subtraction are the ones you replay until sunrise. So what are the physically honest candidates for things that glow where no lamp should be? Start with weather's own party tricks. Inversions and Fata Morgana mirages move distant sources uphill and multiply them into stacked, shimmering phantoms that fuse into orbs when your retina and cortex bargain badly in darkness. Over sharp terrain, those same layers act as ducts that carry photons tens of kilometers along a fixed elevation line. A bend in US 67 several miles east of Marfa's turnout obligingly holds oncoming headlamps at one apparent height for minutes, and if you can't look away, they split and merge like sentient beads as vehicles converge and separate. The choreography is beautiful, mystery is optional. Then there is the electrical sky. Give a ridge a leftover storm anvil's charge above a calm night and its edges start to glow with St. Elmo's fire, violet brush discharges from anything sharp, hissing when close enough to tickle cochlears, lasting minutes if the field is generous. None of this requires the magnetosphere's auroral machinery, it is weather with dignity and an attitude about boundary conditions. And on unfortunate nights in extensional crust, the Apennines, Quebec, Anatolia, the Earth adds its own lamps, earthquake lights, sheets and globes documented at specific times and faults in 2007 Pisco, 2009 El Aquila, 2011 Thoku, 2017 Puebla, and Cousins, with lab work on stressed dolomites and gabbros showing charge carriers that make air earn a glow when the field gets rude. The physics is awkward but terrestrial, the spectacle is real when timing, geology, and sky align. Chemistry keeps a foot in the door. Methane-rich soils and wetland seeps will exhale gas along faults, a cold inversion pond will trap it, a corona at a branch tip or fence wire will put a spark where you didn't order one. The flame that follows rides pale blues and greens, ch near 431 nanometers, C2 swan bands, then borrows sodium from dust and becomes friendlier to our rods. The old foxfire that miners carried, bioluminescent fungus in rotting oak, glows at luminances that are dark adapted I finds generous, a child with a plank makes a ghost at 100 meters, a hiker swears to an orb, everyone goes home pleased. None of this rescues every account, and it does not need to. It replaces 80% of a menagerie with explained animals and leaves 20% alive enough to be worth a grant. Hessdalen is where the stubborn remainder earns instruments rather than insults. The 83 to 84 campaign log nights with radar and optical agreement. The AMS and EMBLA work in 1998 to 2002 delivered multisecond events whose spectra looked like physics and whose photometry let people estimate luminous efficiencies. Apparent speeds ranged from a stroll to tens of meters per second, magnetometers sometimes twitched, VLF receivers occasionally spiked. Teodorani M. Strand floated a dustoplasma picture, ionized air seeded with aerosols from mining waste, soil dust, and droplets, sustained by local fields possibly tied to radon, groundwater flow, or weak rock strain, luminous for seconds while chemical energy and charge trickle in, able to hold shape when wind would otherwise shear a filament. Nobody has trapped a Hessdalen light in a box and made it confess. The record is hours of video, a handful of decent spectra, some radar echoes, and triangulations that put a luminous, slow target a kilometer away and a few hundred meters up, except on those nights when a point darts like a thrown coal and ruins your taxonomy. Valleys are multiplexes, planes, planets, plasmas, and psychology in one sky. You disgrace your methods when you give them one father. Marfa's residue is smaller but real enough to keep grown-ups awake. Subtract the bend in the road beads and the inversion nights, post-frontal, bone-dry air with thin traffic sometimes leaves a bead sitting over Mitchell Flat with no corresponding car and then, rudely, sliding laterally. Ball lightning wants to crash this party because it is a real electrical phenomenon that behaves like a lyre. Bluish, orange, or white spheres from fist to barrel size, lifetimes of seconds, motions independent of wind, sometimes apparently slipping through windows because a microwave-sustained plasma's field geometry, not an object, crosses the pane and renucleates on the other side. But West Texas serves its best shows on calm nights without convective drama. The adult response is not to demote plasma, it is to measure until plasma has to declare itself with a spectrum and a kinematic profile that a headlamp cannot fake. The cure for a century of adjectives is public, synchronized boredom. One station is cute, 3 in a triangle are science. Each gets a calibrated camera, a slit spectrograph, a photodiode, a pocket radar, a VLF receiver, a magnetometer, and a mast logging lapse rates so inversions stop hiding behind hand-waving. Each station's microcontroller pulls GPS time and stamps photons, a shared dashboard paints bearings, ranges, altitudes, and spectra in real time. Most nights will be a parade of cars, planes, and meteors, plus the quiet infrared of ranch houses and, at Brown Mountain, a Chevil's light dome breathing like a sleeping dog. That is not failure, that is a denominator. The small remainder, an oxygen triplet at 777 nanometers pulsing over a slope with no road, a broadband glow with nitrogen rails hanging for 10 minutes in sub-freezing air, a fast point with accelerations that make drones blush, earns an escalation, longer baselines, a drone with gimbaled optics dispatched for parallax, a magnetotelluric sounder listening to the ground, and the logged promise to return the next night instead of arguing about last night on the internet. Wonder survives categorization, it just loses the cranks. Culture is part of the dataset and shouldn't embarrass anyone. Texas put a sign on US 90 because tourists show up no matter what the sign says. The parkway overlooks of railings because people lean too far for apparitions. Hessdalen's winter volunteers keep a tiny outpost blinking in a valley. Nobody in Oslo ever drives through on purpose. A rural economy will tend bar for a mystery. Sheriffs will advise on where not to park. High school physics classes will carry more capable instruments in 2025 than entire university groups could afford in 1985. Fort, the crank patron saint who filed clippings instead of spectra, would have loved this arrangement. Keep the outliers, refuse the clergy of both sides, and do not let explanation become a hack you throw on anything inconvenient. The difference is that our drawers now hold timestamps, wavelengths, and baselines, not adjectives. The orphan events that survive subtraction get named by their spectra instead of their tone. That is not a demotion of myth, it is a promotion of method. If you prefer your romance quantified, stand at Marfa at 10 p.m. on a night after a hot day under a clear sky. Note the temperature drop and the trace wind from the northeast. Watch the first inversion lay down over the flats and the first pair of headlamps on 67 climb into it and freeze at one apparent elevation as if hung on wire. Mark the time. Have a friend on the shoulder by the bend flash high beams at 05 and 35 and feel your chest fall as the orb obediently winks, then stay until 1 o'clock. When the boundary layer decouples and the duck thins and the desert goes dark except for a bead that will not obey anyone's timetable and, for once, carries a warm continuum with an oxygen shoulder and a motion vector that has nothing to do with an asphalt radius. Write it down. Return tomorrow. Refuse to be satisfied. The desert respects only that kind of stubbornness. The oldest good ghost light I trust doesn't arrive from New Mexico or a Norwegian valley. It slinks in out of an English fen with mud on its boots and Latin on its church walls. Autumn, 1770s, Cambridgeshire and Lincolnshire, flat country that taught generations of engineers to hate water and love sluices. Parish physicians with Linnaean ambitions filed letters about blue-white flames a handspan high drifting over peat cuttings near Whittlesea Mere, lights that kept to the lee of hummocks as if they understood wind and manners. Shepherds called them will-o'-the-wisps because a trickster with a candle is the kind of physics medievals could live with. Natural philosophers called them ignis fatui, foolish fires, because nothing flatters a Latinist like a peasant getting tricked. Alessandro Volta, who in 1776 was already collecting marsh gas along the river Ticino the way other men collected dinner invitations, proposed that the swamps were breathing flammables. The recipe, teased out across the next century by chemists with better noses than safety protocols, turned out to be anaerobic decay in saturated soils producing pockets of combustible gas, plus trace phosphorus compounds from rotting bone and fish that can self-ignite at farm country temperatures, lighting the main plume with a match nature didn't bother to strike visibly. The field mark that gives the game away, low, flickering flames that bob and wink in drafts, with a tendency to skitter along ditches rather than climb, belongs to chemistry that hugs ground, not to intelligent light sprinting across horizons like a cavalry. If you want to test the fen men already knew, hold your breath and walk into the path, a thing that disappears in a breeze and refuses to pass shoulder high is burning a joke someone else wrote. The poor cousin of the wisp, the charnel yard candle that Victorians claimed rose from graves, was never about souls, it was about storage conditions. Churchyards in the 18th and 19th centuries kept corpses in saturated, clay-rich soil with poor drainage and a household economy of candles and tallow. The chemistry did what chemistry does when you feed it organics and deny it oxygen. The gases that leak from interments, those same marsh-bred volatiles, pool in hollows and pop in the first cold snap, and if trace phosphorus is in the mix, ignition arrives without a visible parent. Coroners made peace with this 100 years before television did. The more honest grave diggers wrote it down without adjectives, lights low to the ground, duration measured in seconds, color pale, behavior tied to breeze and temperature, not to anniversaries. There is enough poetry in the simple sentence, blue fire walk the sod, without inventing a theology that can't pass a wind test. Sailors had their own lights and a better paper trail. St. Elmo's fire, named for a Mediterranean martyr who never asked to be turned into plasma, shows up in logbooks across centuries because keeping your ship alive teaches you to write down the weather that tried to kill you. Antonio Pigafetta, the Venetian who kept Magellan's papers in 1520, marked down the Santo Anselmo light that played on yardarms during a storm in the Strait. English pilots out of Plymouth and Portuguese captains out of the Tagus made similar notes in the 16th and 17th centuries, describing violet fringes on mastheads and sprits, sometimes two dancing lights at once like a joke the heavens wanted to share with the watch. The mechanism is laboratory simple and shipboard rude. In strong field weather with rain, hail, or dust, the atmosphere goes from sullen to conductive, sharp conductors on a moving whole concentrate electric field. Corona discharge paints corners, rope ends, and spars with glow and hissing that sounds like a badly tuned radio played through oak. The color, bluish toward violet at night, belongs to ionized air. The preference for points and edges belongs to geometry. The way brightness tracks the malice of a squall belongs to physics the size of a cloud. It isn't a ghost, it's a barometer with theatrical ambitions. Mariners also recorded lights the ocean itself made, huge sheets of dairy white that ran for hours under clear sky and tried to convince a nervous midshipman that a city lay just below the surface. 19th century logs from East India Company, Royal Navy, and clipper captains sailing off Sumatra and Java read like a slow-motion hallucination, miles upon miles of milky light, lens bright around the bow, with no breakers and no moon. The culprits are alive and microscopic, blooms of plankton and symbiotic bacteria that flash when disturbed, in rare cases, off the Horn of Africa and north of Lombok Strait. The bloom's density and smooth stratification turn a sea into a sheet. A wake cuts black, not because a supernatural switch turned the lights off where the hull passed, but because hydrodynamics mixed the layer that had been shining into deeper water without the density. An oxygen regime that sustains the glow. Mariners didn't need a Latin name to run the test, they dropped a bucket and watched the glitter under the lip. The paper trail is exact, dates, latitudes and longitudes, wind, cloud, sea state. The mystery evaporates under numbers and survives under adjectives, which is how folklore likes to live. Asia's ghost lights come with cosmologies that fold physics into morality without losing the geometry. Edo period Japan drew hitodama, floating globes said to be the souls of the floating dead, on woodblock prints with the colors right and the heights right, bobbing near forest edges and rivers, a meter or two above ground. In Bengal's Sundarbans and the delta around Barisal, fishermen feared Alaya lights, pale glows that hovered over creeks and mangrove banks on humid nights in the pre-monsoon heat, and everyone knew a story about a boatman who chased one and ran aground. The human part of the file, written in court records and missionary letters as much as in folktale collections, has a common spine, low elevation, saturated soil, organic load high, late evening or pre-dawn, light wind, bad visibility over waterlogged ground. The physics is identical to the English fens except for the soundtrack and the calendar. The cautionary note in both cultures is the same one you can write on a child's hand: don't chase lights into a swamp if you want to live. Australia's minute has the dignity of being loved by a continent, feared by stockmen, and measured by a professor with a pickup. Boulia's country, Channel Country, red soil and low relief, began printing minute lights in settler diaries around 1918, but Aboriginal stories long predate that coincidence of cattle and war. The behavior, white to yellow points that hover just above the horizon, sometimes splitting or changing size, apparently following riders at a walking pace, screams optics before it volunteers spirits. In the late 1990s and early 2000s, Jack Pettigrew out of the University of Queensland did the painfully boring thing folklore hates. He drove the quiet roads on winter nights with thermometers, cameras, and a map of likely temperature inversions, then replicated the effect with known lights, headlamps, campfires, beyond line of sight. A strong inversion builds a refractive duct near ground, light from a distant source curves and skims along the duct-like sound under a temperature cap. If the duct bends upward and the ground falls, you can see a car 30 or 50 miles away as a hovering orb standing a degree off the horizon. The parlor trick that sells it to people who don't believe in ducks is how minute behaves when you drive toward it. The angular size changes in a non-intuitive way because you are not approaching a thing but driving along a ray within a waveguide that moves with the air. Tell that to a drover in 1922 and he'll laugh, then nod, because he knows a horizon and a mirage when he sees one. Now give him the temperature profile and he'll stop giving you side-eye. The American heartland bred its own lights where roads were scarce, horizons were playful, and newspapers loved a headline that could summon a crowd to a gravel turnout. In the Ozarks, on the line between Oklahoma and Missouri near Hornet, locals began calling an amber white light the Devil's Promenade in the early 20th century, 50 years before Route 66 poured an artery of headlights into the region. The vantage geometry did the multiplying. A valley with a clean line of sight, a gentle inversion on autumn nights, and a 2-lane miles away that the viewer could not see by day produced a single light at night that marched and danced without a foot. Decades later, students with a theodolite and a transponder did the simple, adult test: radio the friend on the far road to switch lights, then watch the spook blink in perfect synchrony. Northern Michigan's Paulding Light earned a similar retirement party when college kids in 2010 got atop a ridge with binoculars and timed the mystery to US 45's curves. The physics was not insulted by the romance, just amused. Arkansas's Gurdon Light, Pell, blue-white near the track, falls to the same family, ducted headlights bent by night air into a line of sight that isn't there under the sun. The enduring lesson in each county is not that people were fools, it's that a flat world at night writes parlor tricks into air, and a favorite gravel lot will launder them into legend between a first date and an obituary. Brown Mountain's pre-automobile chapter is an x-ray of how a modest ridge can bully eyes into poetry. Before the big automobile years, before US 70 scooped up headlight inventory for a century, the 1910s saw Burke and Caldwell County residents walking out to Linville and Wiseman's View with a thermos and a willingness to freeze for the reward of a light chorus over the gorge. Cottage industry took off, boarding houses printed postcards, a cigar box on a porch became a soda fund for the neighborhood boy who could point and say, there. The earliest investigators weren't cops, they were engineers and railroad men with field glasses and a love of schedules. By 1913 to 1916, they were already cross-referencing train times to flares seen from the overlooks and discovering correlations they didn't enjoy saying aloud. A decade later, geologists with transit levels proved the boring point, a combination of campfires, torches, locomotive headlights, and later autos framed by spur ridges and inversions accounts for the majority of the show. The part that isn't trivial, brief, color-shifting glows with no obvious parent in off-season nights, remains a small residue best dealt with by instrument kits, not adjectives. The oldest notebooks around Brown Mountain are not embarrassed by the later math, they still read like adults, dates, bearings, times, winds, and the occasional expletive written when nothing lined up with the schedule. Marfa's oldest sighting lives in a bindle with dust and nostalgia and a margin note that simply says 1883. Robert Reed Ellison, a ranch hand driving cattle southeast of town, supposedly wrote, or later told, a simple sentence. He saw lights to the southwest, above the Mitchell Flat, and assumed they were Apache campfires until they kept appearing in places where no trail supported a fire, on nights no one kept a camp. The trouble for the archivist is that the earliest robust printed mentions show up decades later, when cars and the war and a viewing turnout east of town had already taught glass to face a desert. That doesn't kill Ellison's note. Memory can beat a printing press. What it does is force the adult to admit priors, low horizons, temperature inversions in fall and winter, long straight rights of way beyond obvious hills, and a sky whose clarity lets far things misbehave. Pre-war pilots flying out of Marfa Army Airfield in the 1940s wrote about the lights too, training notes, not poetry, and at least one crew of oilmen the decade before made their own grudging admission that headlights on the Alpine Road are some of the mysteries. An honest Marfa file today treats the 19th century cattlemen with respect, the mid-century pilots with gratitude, and the far-road ducted headlight class with the contempt of a solved case. The remainder is smaller than the brochures, it is not zero. Long before earthquake lights became a modern brawl between seismologists and photographers, there were countrymen who wrote in diaries what their sky did during weeks when the ground would not stop muttering. The New Madrid sequence of 1811 to 1812 in the central Mississippi Valley produced enough stories to paper Missouri, luminous flashes near the ground on freezing nights, blue-white glows that ran along the horizon like a distant barn burning and then went out, faint crowns around fence posts just before the shocks. San Francisco's 1906 disaster printed similar notes, with credible witnesses describing silent sheet-like glows just before the main shock that humbled their vocabulary. The physical mechanisms proposed are unromantic and plural. Charge separation on fresh fracture surfaces in rock, a flavor of triboluminescence, corona discharge on grounded conductors under stress, piezoelectric fields in quartz-rich strata bootstrapping local ionotation near ground when fault patches load and unload. The records that help are those that did not try to win a bet, they are bishop's letters and civil engineer's notes, with minutes to midnight and a wind rose scribbled in the margin. The cultural lesson repeats, if you write, we saw a light, without giving the temperature, a map, and a time, you donate your story to the same shelf as Hitterdama and Will-o'-the-Wisp. Europe carried its own portable lamps into folklore and field notes, and the places they appeared are precisely the places your shoes sank. Bavarian peat cutters in the 1820s kept journals that read like a chemist's almanac, notes on flame color, wind, wetness of the peat face, because they were paid by the day and a flame on the wrong side of a ditch steals a day. Norfolk fens in the 1840s had enough surveyors with compasses and water levels that you can reconstruct, from their margins, how often the low flames favored the downslope side of a drain where gas collected and how seldom they cleared a reed's height. French inventors working in the 1850s and 1860s on gas lighting in marshy communes ran a small industrial revolution in reverse. They learned how to vent pits and line channels to starve the spontaneous flames and send gas to the lamps they could charge a fee for. A mystery light loses its appetite for theatre when a mayor's ledger can bill it. Even the theatre of the cemetery lantern, glowworms and fireflies staging a farce across hedgerows, shows up earnestly in natural history from the 1600s onward because people who rose before dawn to check traps paid attention. Foxfly, the dim green smear of bioluminescent fungi. Eating hardwood stumps in humid forests, dresses itself as a will-o'-the-wisp only for eyes that have forgotten to be patient. Travelers in the Carolinas in the 18th century described those faint, steady pads of light on the forest floor on July nights, distinguishable from flame by their reluctance to move and from insects by their refusal to blink. If you have ever walked a trail in a pine forest with a rotten log underfoot and a thunderstorm's humidity around your shoulders, you already know the color. A child with a stick and an adult with a notebook could have solved this in 1700, sometimes a child did and the adult forgot to write it down. Not all mystery lights hug the ground. The Naga fireballs on the Mekong, November crowds between Nong Khai and Vientiane, tails on the river glowing like beads rising from the water, tell you, if you read the calendars, that the spectacle peaks on cool, still nights at the end of the rains when festivals and boat traffic give you more stimuli than your eye can sort. Some nights, yes, orbs appear to lift out of dark water without a spark, and local television crews capturing them give you a geometry you can work with the next year. Other nights, the river is filled with tracer tongues, flares, and bottle rockets fired out of boats as much for noise as for belief, cameras pointed upriver toward Laos collect light the brain, primed by expectation and a good story, will merge. A rare low-energy combustion from the river's skin is possible, biogas in slick eddies finding the right eddy and an ignition in the air that nobody sees. But the yearly rhythm and the distribution of rises along the banks warn you that most of what is felt as a visitation is human choreography reflected, refracted, and misregistered across a water dark enough to lie for fun. One of the quiet minor classics of the genre is how often mystery lights make friends with rails rather than roads. Before highways brought a new supply of headlights to every county, steam trains offered point sources, itinerant, bright, and clockable, that could be bent by ground-hogging inversions into lights halfway to the horizon you did not know how to reckon with. Across the 1890s and 1900s, rural papers in the United States and Britain regularly ran phantom locomotive items which, when you subtract the adjectives and lay an ordnance survey map beside the column, resolve into exactly the kind of refracted, ducted sightings we later learned to blame on Fords and Chevrolets. The lesson isn't that our great-grandparents lacked sense, it's that an inversion does not care whether its ray bundle contains a kerosene lamp or a quartz halogen, a coal furnace's glow or a xenon arc. The waveguide wants a point source and a viewer who can't see the source, the rest it supplies out of thermodynamics. If you plot these traditions, WISP, St. Elmo, Minute, spook lights, earthquake lights, on a map of environments, the clusters become an almanac rather than an atlas. Marshes and deltas in warm seasons give you combustion, mountain basins and plains under winter inversions give you mirage and ducting, coastal storms and high field conditions give you corona, valleys under tectonic stress give you discharges and glows that escort earthquakes like unwanted brass bands. The mechanisms are plural but stingy, they reward notebooks, not incantations. The oldest credible records, the ones that still deserve a night and a thermos, are the ones that tell you where the wind was and what the air had been doing for hours. When a 1790s Fen doctor writes, light blue, no smell, flame rises behind a hummock where cattle pounded the turf to slurry after 3 hot days, he is telling you chemistry. When a 1915 Carolina sawmill worker writes, a light that walked the ridge every hard frost night at 9, sometimes 2, he is reporting an inversion on a schedule that likely tracked a rail timetable and the thermal cycle of a valley. When a 1520 pilot writes, a tongue of blue fire on the mizzenmast that changed to 2 tongues when the hail came, with the singing in the cordage, he is logging a storm's field quirks. The common culture across centuries is evidence, not angels. The other commonality is that for every honest witness with a good pencil there is a newsroom that learns how to bend 2 unrelated stimuli into a single animal. That temptation is the same one that turned a Tuscan football stadium's silk into cargo from a saucer and a Kentucky fence into meat from heaven. Ghost lights love adjacency, a lantern on a far road and a train on a nearer bend, a glow on a power line and a single firefly who refuses to take your experiment seriously, a halo on a ridge and the rumor someone brought from the next county. The cure is ridiculous in its simplicity, and the best witnesses in the 19th century knew it almost instinctively: time, direction, distance, wind, the willingness to let boredom win. It isn't that romance is the enemy, It's that romance with a stopwatch remembers its manners. If all this sounds like a lecture smothering a field guide with equations that won't sit still, notice what survives after the arithmetic did its murder. Those Japanese prints of floating blue balls over a river are as beautiful after you learn about decay gases as they were when you thought a priest had died badly. An Australian road under a frozen sky still produces the lovely wrongness of a light that follows your bumper even after you've mapped the duct. A North Carolina gorge at 10 p.m. in October is still worth a thermos, even if you spend most of the night picking out cabin lights and a local's illegal bonfire. The hard part, then as now, is letting wonder and method room together without getting each other's laundry dirty. The historian's job is to put the early sightings in the right weather. When you do, you see that much of what our ancestors called lanterns and spirits were the atmosphere playing with charge and heat, that the sea loves to paint itself when microbes find the right broth, and that valleys and plains can bend light the way a glassmaker bends a stem. The moderns with spectrometers and azimuths didn't make that truth, they rediscovered it with better gear. The kindness you owe the old reports is to let them keep their poetry while insisting on their measurements. If you inherit a ghost light story without a wind, give it back. If you inherit one with a wind and a time, go stand where the writer stood and let the air decide what class of trick you get treated to tonight. The night you finally get serious about lights, you stop behaving like a tourist and start behaving like a lab. You pick a baseline before sunset, 3.2 kilometers between the Marfa viewing area pull-off on US 90 and a survey pin on Mitchell Flat, or 1.2 kilometers across the saddle that looks north over Hessdalen, or the neat 5 kilometers triangles you can draw between Wiseman's View, Lost Cove Cliffs, and the Parkway overlook near milepost 310 above Brown Mountain, and you lay out optics as if you were cross-examining the sky. A camera with a fixed plate scale gives you angular rates in arcseconds per frame at 30, 60, or 240 frames per second. A diffraction grating ahead of a second imager prints wavelength like a barcode, so a naive yellow splits into the sodium doublet at 589.0, 589.6 nm, or keeps the smooth continuum of a hot particle cloud. A GPS puck slaps sub-millisecond time on every frame so parallax can stop being polite and start solving for range. Meanwhile, a pocket photometer sampling at kilohertz rides shotgun to write the light curve, because an orb that breathes quasi-exponentially with a 1 to 3s time constant is a combustion or dust-to-plasma problem, whereas a pair of spikes at 1 Hz is a slow hazard flasher in a valley with good acoustics pretending to be divine. If you want the adult primer on why this works, look at the valley that forced grown-ups to do it first. Between December 1981 and spring 1984, Hessdalen turned a rural glacial trough north of Rose, almost equal to 62.8 degree N, into a semester-long practical exam. Engineers, students, and patient locals triangulated luminous events, pulled spectra with amateur-grade optics, and even logged radar returns. When the initial frenzy cooled, they left the Hessdalen automatic measurement station running from 1998 onward with all sky cameras, photometers, magnetometers, and a VLF receiver that learned to be bored for weeks at a time and then confess a 10-minute glow at 23:17 on a Tuesday with much less drama than anyone deserves. The best nights show a broad continuum with atmospheric shoulders, oxygen red at 630 nanometers, oxygen triplet near 777 nanometers, occasional sodium at 589 nanometers, plus photometry that puts the hanging light in the tens to hundreds of watts of visible emission, which is small by lightning standards and huge by, that's just a lantern, standards. Atmospheres lie for a living, so the first hard science is refraction with a mean streak. On clear nights the ground radiates heat into space, the air within the first 10 to 50 m cools faster than the air above, and the nocturnal inversion sets up with a refractive index gradient of order 10.7-10.6 per meter, enough to bend light by fractions of a degree over tens of kilometers. That turns basins into optical waveguides. Put headlamps on US 67 southeast of Marfa or a locomotive's lamp somewhere in the Catawba Valley west of Lenore, and a superior mirage can hoist their rays above intervening terrain. Focus them into shimmering blobs, split them as turbulence changes the duct, and make two distant vehicles look like one hovering bead that divides and reunites as if negotiating a contract. When you test this with the most embarrassing experiment imaginable, one person counting car clusters on 67/90ths by radio while another tallies, mystery, counts from the viewing area. The curves ride together on busy weekends and sag together after midnight when traffic dies, making liars of many good yarns but leaving a residue. The USGS already wrote the footnotes a century ago. In 1922 their fieldman triangulated Brown Mountain's ghosts against train schedules and brushfire reports and found a map of optics and culture rather than a demon nursery. The night after a flood washed out one segment of track, other lines and new roads still fed the Mirage Corridor, because inversions do not read municipal maintenance logs before misbehaving. Once you accept that air bends light like a bored stagehand, you learn to read spectra the way a pathologist reads stains. A ducted halogen headlamp keeps a tungsten light continuum, a sodium street lamp, or a brush fire liberating sodium from dry vegetation, wears the D-doublet with pride. And lead is a comb of phosphor emissions pasted over a blue pump. An air plasma throws the OI lines at 630 and 777 nanometers and the N2 second positive system into the blue-violet, with a continuum if hot dust is along for the ride. Project Hessdalen and the later Italian-Norwegian EMBLA campaigns caught all three classes in the 1998 to 2002 seasons, nights that were plainly cars pushed through an inversion, nights when nothing but aircraft strobes answered, and a small, stubborn set in which triangulated lights hung a few hundred meters above slopes for seconds to minutes while spectra said, ionized air plus particulates, not lamp. That is the family you keep when you subtract the obvious, and it is exactly the family that makes physicists reach for ball lightning taxonomies rather than for YouTube. If you want to know what a desert light is made of, build a budget the way an electrician would. Visible emission of 100 W for 300 S is 30 kJ in photons, at a generous luminous efficiency of 5% in dirty air, that's tilde 600 kJ of input energy. Radon exhalation from fractured schists or mine waste can ionize local air. Baroxy defect, P-holes, migrating through stressed rock can add charge carriers to the near surface. Groundwater flows can arrange field gradients. But none of these on their quietest Tuesdays pay a 600 kJ bill for a single stationary glow unless the geometry and weather cooperate like saints. That's why the self-sustained dusty plasma model has traction in Hessdalen, a weakly ionized aerosol, soil dust, metal microcontaminants from slag, water droplets, held together by a mix of electrostatic cohesion and low-temperature chemical heat can glow modestly for tens of seconds and drift at walking pace in stratified air. When the valley is generous, radar sees a cross-section where the light is. When the valley is stingy, your instruments catch only the photometry and your pride. Either way, the line budget is physics, not angels. The human visual system is the saboteur in the room. Under scotopic and mesopic conditions your rods vote blue-green, Perkins shift, making white LEDs punch above their weight and red taillights die to rust. Microsaccades turn pinpoints into motion. Autokinesis invents drift if you stare at a single light against black for 20 seconds. PWM drivers in LED lamps alias with camera sensors and make a hard 50 to 200 Hz flicker look like intention. A spectrograph will cheerfully betray these tricks. A tungsten continuum tells you, car window, not cherub. The phosphor comb and blue pump scream, lead. Silence in the VLF band when your eyes swear the heavens are upset says, no. Sprites, no spherics, just your cortex negotiating with darkness. In Hessdalen this contrast is brutal and therefore educational. The same station will spend months printing nothing but stars and a few aircraft, then cough up a 10-minute continuum plus lines event at 23:17 that leaves photometry, geometry, and a line list any lighting engineer would sign with a trembling hand. Brown Mountain's physics is gentler but equally underhanded. Autumn evenings set an inversion over the Catawba corridor. Humidity and aerosols steepen refractivity. 30 to 70 kilometers sightlines let a single lamp smear into an orange pulse near a ridge. Brush fires right sodium into the sky. And the parkways geometry is a mirage factory that never asked to be famous. A trivial, humiliating test, bearing with a hand compass, friend on a 2-lane road flashing at agreed minutes, works so predictably that repeating it feels like telling the same joke twice in one party. And yet 3 or 4 nights each year leave you with a self-luminous patch above a ridge long after the last Harley has gone home. Leave those alone, point a slit at them next time, earn the right to keep them by measuring them. Marfa is where geometry becomes a character. US 67 and the Union Pacific throw artifacts toward the Mitchell Flats like a slot machine. Nocturnal inversions lay a horizontal waveguide. A curve in 67 several miles east lines up a string of oncoming headlamps at a fixed elevation so neatly that they stand like a Roman legion when the duct cooperates. Subtract all that and, especially after midnight in good air, you sometimes keep a bead that parks over the flats with no cooperative car and then, rudely, slides sideways. You will be tempted to mutter, ball lightning, and on thunderstorm nights I'll join you. On the placid evenings when the show is best, you'll have to earn your nouns with spectra and parallax rather than with romance. Ball lightning is the unruly cousin who actually does attend family reunions, and we already stole its homework. In July 2012 near Qingyang, China, a slit spectrograph caught a 1.6s luminous sphere birthed by a strike into Lurs. The spectrum carried the fingerprints of dirt, Psi, Ca, Fe, Na, sitting on a broad continuum like a chemistry lecture that forgot to be shy. Lab cousins exist, Silicon arcs over wafers make luminous droplets. Microwave, air torches, make centimeter plasmoids that live for fractions of a second after power is cut. Soil vapor models produce orange glows with silicon family lines that look rude next to that Chinese field tape. The energy scales are modest. 102 to 103 J internal for small orbs, tens to hundreds of watts visible, and the behaviors are pedestrian. Buoyant creep at ~0.51 m. S in stratified air, death by pop when a chemically tired aerosol ends its tiny life. You can be enchanted and honest. Nothing in the Qinghai Tibet spectrum asked you to rewrite cosmology, but everything in it asked you to bring a spectrograph to the next storm. So what do you put on a ridge and when? 2 images at a known baseline solve for distance by parallax. A diffraction grating gives identity. A photodiode at kilohertz sampling tells you weather. The thing flickers like a utility or breathes like a flame. A VLF-ELF loop, 3 to 30 kHz, tattles on lightning family transients. A magnetometer sulks until there's something to notice. A ceilometer or backscatter lidar sketches the inversion. ADSB logs pry aircraft out of your hair. Traffic counts humble you when car curves match. Mystery, curves on a Friday. You pre-register the geometry and the scoring to keep your future self from cooking the books. It is not glamorous, it is cheaper than one season of cable television about demons. The geology and chemistry aren't innocent either. Granite and gneiss with peroxy defects can liberate positive hole carriers under stress. Those carriers migrate meters per second toward the surface and jack up local ionotation. Valley winds bring humidity at the right heights. Fences and ridgelines concentrate fields. Corona takes the stage in blue-white, sounding like a faint hiss. Smelling like ozone and nitric oxide and the faint Baker-Arong perfume people keep writing in notebooks. Add radon leaking from fractured schists or old mine workings. Alpha decay in cold air seeds ions and starts chemistry. Aerosol metals from mining spoil or traffic dust lower ignition thresholds for slow, orange combustion. None of this pays every bill. All of it sketches the preconditions for a valley that sometimes lights itself without asking permission. Because this is an audio course and not a grant proposal, I owe you numbers without equations. Ducting that lifts a headlamp's ray 0.2 to 0.6 degrees over 40 kilometers is comfortably commonplace when a 4 to 8K inversion sits in the lowest 100 to 300 m. The hover altitude you think you see from the Marfa pull-off is better thought of as the apparent elevation where a curved ray crosses your sightline, often 0.2 m above a distant ridge, not 100 m over the flats. A slow plasma bead with 100 W visible power radiates like a 2500 to 3500 K radiator in the visible. A cooling curve of a few seconds gives you an effective heat capacity that says dirty air and chemistry, not lead. Oxygen at 777 nanometers with no sodium is a different animal than sodium wearing its 589 nanometers grin. Nitrogen's 337 nanometers band needs clear optics or a UV-sensitive sensor to prove you're looking at air and not glass. Put a rotating polarizer on the lens and scattered light declares itself. Polarization flatness with a continuum argues for self-emission. These are adult sentences because they let you sort the pile before ideologies start shouting. Perception remains the trapdoor. Pilots have been taught for decades to distrust autokinesis because a lonely light on a dark background will drift in the oculomotor system and manufacture intent. The rest of us greet the same neurology with a cooler in the truck and call it Saturday. Put a spectrometer on the same light and it becomes a tungsten continuum while your brain still whispers, choreography. Put a VLF loop next to your chair and you will hear a noisy sky. The night sprites are genuinely dancing and a stay silent ceiling on the dozens of nights your prose would otherwise have sprouted adjectives. Put a second camera on a distant ridge and parallax will win fights your cleverness never could. By now the taxonomy has earned its keep. West Texas nights sort into ducted headlamps and train lamps, majority, aircraft and meteors, respectable minority, and an obstinate remnant that behaves like low-power plasmas. Sometimes even on storm-quiet evenings when ball lightning doesn't get to hog the script. Norway's ledger is similar but with better physics, aircraft and planets, ducted vehicles up valley, auroral imposters, and a residue with spectra and radar. North Carolina's ledger is generously mundane, headlamps, brush fires, and the parkway's flattery of optics, with the odd post-storm glimmer that earns a control night and a baseline. The point is not to sneer, it's to make wonder earn its rent by paying with spectra, geometry, and weather profiles. If you're hunting for thresholds, you can steal them from storms. Dusty plasmas in open air need charged aerosols plus weak fields plus humidity that won't short everything out. Think 40 to 90% RH, light winds less than or equal to 2 meters per second, and a valley that gives you stratification. Corona on rock likes corners and edges and tolerates higher winds so long as field concentrates, rich crests, fence posts, sharp boulders. Ducting once calm, lapse rates inverted in the first 100 to 300 m, a day that bled heat cleanly after sunset, and a distant road at just the right height. The ethos is stoic: pre-tag your duck nights, your corona nights, your combustion nights, and then eat boredom until the sky cooperates. What you should not bring to the ridge is a single cause religion. Piezoelectric rock law has a grain of truth but not the energy budget. Radon can be an accomplice but rarely a lead. It's all cars, collapses on the wrong winter, and it's all plasma, collapses on the right Friday. Valleys multiplex, headlights, brush fires, planets, drones, plasma cousins, and the occasional meteor share a sky. And a field that refuses categories becomes a debate club for partisans instead of a measuring device for adults. If you must keep a little romance, and you must, because you're human, keep it in the 2 or 3% of nights that survive parallax, spectra, traffic logs, ADSB, and your own bias. You will be more persuasive when you announce, 3 mysteries live here, we've retired one and are strangling the second, the third keeps showing us oxygen at 777 nanometers on moonless Tuesdays. That sentence pays its bills. And if the desert insists on teaching you humility, borrow a page from the thunderstorm literature that we wrote elsewhere in this series. The Chinese spectrograph that finally pinned a ball's chemistry in 2012 wasn't brave, it was bored, aligned, and time-stamped. Lightning networks, ceilometers, and microbarographs have become cheap enough for county budgets. $500 CMOS cameras run at 240 frames per second. $1,500 USB spectrometers will pull a sodium D doublet out of a whisper and an oxygen triplet out of an honest glow. A $20 microcontroller reads GPS ticks to plus or minus 1 millisecond and stops witnesses from arguing about clocks. If you want Hessdalen level clarity in Marfa or Brown Mountain, put 3 such boxes on a ridge for a season and tell the public in advance that 99 nights out of 100 you'll record stars, dew, and coyotes, and that the single night you don't will be measured like a crime scene with better manners. The last physics is the kind you can feel on your teeth. Electric fields concentrate at edges, wires and sash frames make parallel plate toys for charge, window corners are friendly to both corona and microwave-fed plasmoids. Ducks select wavelengths but are blind to your superstition. When witnesses insist a light, preferred the mantle, or hated crossdrafts, they are writing poetry about boundary layer flow and field gradients. When a Brown Mountain orb keeps its altitude over a ridge for minutes, the parallax will usually tell you the apparent line of sight at 0 to 2 m above a far slope, exactly where ducted rays like to travel. When a Hessdalen glow strolls in crosswind at 0.8 ms and dies with a soft pop, the photometry, the wind sensors at 1.5 magl, and the acoustic spike will line up like adults. If a mechanism can't fake those behaviors in at least a few settings, it doesn't deserve your weekend. Everything here says the same impolite thing in different accents. Hard science doesn't murder wonder, it teaches it to file taxes. Marfa's ducted lights are a planet's refractive index doing party tricks. Brown Mountain's hovering pulses are inversions with a sense of humor. Hessdalen's residue is air and dust learning to glow on meager rations. And ball lightning is chemistry and electromagnetic geometry throwing a tantrum for a few seconds after a strike. None of that stops you from pitching a chair on a ridge and hoping for one good night. It just means that when the good night arrives you'll leave with wavelengths, angles, and a time series instead of a story that evaporates when the sun shows up. And if the only thing your kit captures is boredom and dew for a month, congratulations, you have the denominator the folklore never gave you. Ford would have started, as he always did, with paper. 1919 in Manhattan and 1923 in Bloomsbury, long before roadside overlooks sold stubby binoculars and parking lot tacos, he stitched together reports that moderns would file under 3 tags. Moving headlights seen where no highway should be, floating orbs with a temper, and steady glows above wet ground with all the charisma of a porch light, then refused to let any category have the last word. He pulled 19th century ship logs from the proceedings of the Royal Society that described wheels of light turning in the Atlantic at 10 to 12 knots off Pernambuco, 1864 to 1870. Clipped parish notices about marsh fire on the fen edge near Ely, 1850s, and tucked them beside a Virginia mountain letter about a stationary glow on evenings after rain, 1882. A generation later, after a USGS geologist named George R. Mansfield tramped North Carolina slopes in 1922 and blamed a fair fraction of Brown Mountain's mystique on train headlights from the Southern Railway and brush burns in the Linville Gorge. Fort smiled in print but didn't yield. He treated Mansfield's rationalisms as entries to be shelved next to the rest. The real instruction in his method was tonal: list everything, doubt everyone, snicker at anyone who claims closure. and keep an index because you will need it when the next county fair invents airglow. With beers. That posture, rude and useful, scales beautifully to the modern mess called Marfa, Hessdalen, and Brown Mountain. It also points at our way out: stop deciding, start measuring, then earn a decision with instruments that bully stories into numbers. The present isn't short of instruments, it's short of discipline. In the Hessdalen Valley of central Norway, 62.8 degrees north, 11.1 degrees east, a small team that had no patience for adjectives built an automatic station in 1998 with an all-sky camera, a triaxial magnetometer, a pair of optical spectrographs, and VLF/ELF receivers, then let it run for years. In 2001 to 2004 the rig grabbed spectra of luminous events that showed broadband thermal emission riding a few familiar lines. Oxygen's green 557.7 nanometers shoulder showed up on some nights. Sodium's 589 nanometers doublet flirted with a few frames. On others, nothing discrete at all. Just a hot continuum and the stubborn fact of a moving, resolved source registering on multiple cameras with a baseline of a few hundred meters. That sounds mundane until you price all the alternative futures a single spectrum kills. Headlights at 7 to 10 kilometers line of sight don't throw oxygen airglow into a slit. Distant car lamps don't produce magnetometer squiggles with matching timestamps. Plasma knots do. In West Texas, near 30.2 degrees north, 103.9 degrees west, the Marfa crowd in the 2000s grew more organized than their 1950s predecessors with 8mm film and optimism, hauling low-light CCDs to the US 67 overlook and, when they were serious, logging azimuths and timings so they could triangulate against trains sweeping the Mitchell Flat and flights dropping into Alpine Casparis. Brown Mountain, 35.9 degrees north, 81.9 degrees west, did a gentler version with synchronized DSLR pairs at Wiseman's View and the Blue Ridge Parkway Milepost 310 pullouts. The nights when 3 observers wrote down the same azimuth and the same rise times, and all 3 entries lined up with a head-on Norfolk Southern movement through the gorge, should have retired 80% of the chatter. The residue that refused to timetable, short drifts only a few degrees wide, without oncoming schedules, didn't become angels, it became a to-do list for spectrometers. Fort, whose famous appetite for the damned never actually included a lab bench, would have liked the paperwork anyway. If you want the 2025 adult version of a Fortean file card, build the stack that convinces a judge. First, timing that isn't a guess, GPS-disciplined clocks on every camera, sub-millisecond hard stamps embedded in each frame's EXIF. Second, geometry, at least 2 stations separated by 2 to 8 kilometers, with known baselines surveyed to a meter, so a single azimuth at each becomes a 3D track. Third, spectrum, a cheap 600 to 1200 lines blazed grating on one of the lenses, slave to the same clock, so a bright dot yields either a smooth plankish curve, a sodium doublet, an oxygen line, or nothing but a muddy smear that tells you the source is probably lead waiting to embarrass you. Fourth, the guilt machine, a local ADSB MODES receiver logging every ping from transponder-equipped aircraft to 250 kilometers, elevation angles attached, a remote ID database for drones if you can get it, a scanner for railroad traffic, and the TLEs for obvious satellites so your gear knows when a Starlink flare will cross your field at 1917. Layer on weather, a radiosonde profile. Cape, inversions, 0 to 3 kilometers wind shear, from the closest 0012Z launch or ERA, 5 reanalysis, surface fields from a field mill measuring the fair weather vertical gradient, 100-200 VM in normal conditions, because spider silk is not the only thing that pays attention to charge, and microbarograph strips sensitive enough to hear infrasonic, microbaroms, from distant seas, because those pressure wiggles tell you when ducting and mirages are likely. Then, because the lights like to mock us from wet edges, throw in a soil gas probe for CO2 and a shallow resistivity meter on a traverse across the spot where people say, it stands, so you can learn whether groundwater plays matchmaker with charge. A 2-month deployment with that stack at Marfa, and a matching one in Hessdalen during a winter campaign, would do more for adults than 80 years of adjectives. Once you start treating the world like a lab, most mystery lights die in a statistically satisfying way. Ducted headlights inside low-level temperature inversions pick up on airglow nights at 9 p.m. local when the radiative balance over dark desert collapses and you get a refractive layer that bends light back toward observers. The geometry can be drawn with rays and an index of refraction profile like a sophomore problem set. Long-burn military flares hang on parachutes for 4 to 6 minutes and drop 1 to 2 meters per second in smooth air. The sodium yellow in their burn is open-book chemistry. A 90-second cadence of wink-outs behind a ridge points a Chilean miner's headlamp at the same culprit as the Arizona National Guard. Ball lightning, a few seconds of drift, then a pop, radius in the 10 to 30 centimeters class with a hot continuum and occasional silicon, iron, calcium lines. Belongs to the storm catalogue and doesn't get a blanket invitation to dry air valley folklore. Scintillating stars near temperature gradients hop when you stare at them and only stop misbehaving when a tripod humiliates your vestibular system. Satellite trains flare on predictable passes with magnitudes anyone can print next to a calendar. But even after that culling, a residue remains, especially in valleys with unusual ground chemistry, unstable winter boundary layers, and a catalogue of reports that predate headlights and parachutes. Those are the nights that pay for all the boring ones. The fashionable physics for that residue sits at the low-energy end of plasma and solid-state physics rather than in the afterlife of kerosene. Think dusty plasmas where micron-scale particles, lifted by shallow convection and charged by ambient fields, self-organize into luminous knots that drift along equipotential surfaces for tens of seconds. Think piezoelectric rock under strain at rift edges, the St. Lawrence Valley, the Apennines, the eastern flank of the southern Appalachians, where positive hole defects propagate an ionized air that then glows with a spectrum strong in oxygen at 557.7 nanometers and 630 nanometers. Think localized corona. Discharge along damp tree edges in inversions that crawl because your oculomotor system is happy to invent a glide for anything that flickers at a high enough frequency. Each of those mechanisms has a life in the lab. Dusty plasmas are what students make in RF chambers every week. Stressed rock current and earthquake lights showed their faces near the 1975 Haicheng M7.3 and 2009 El Aquila M6.3 sequences, with videos from Japanese towns in 1965 and 1968 that look suspiciously like the apologia the skeptics always demanded. Corona is so eager to reveal itself that every humid July thunderstorm brings it to your fence post if you're willing to turn the porch light off and listen. The hard move in the field is to sort which nights are just inversions and headlights from the smaller set where the ground, the sky, and a valley's geometry conspire to build a low-temperature light source that can roam. That sorting needs spectra and ground truth, not belief. Ford, who invented an attitude without ever building a spectrograph, would have filed those spectra alongside the jokes. He treated luminous wheels at sea in the Book of the Damned with a blend of mockery and diligence, then in New Lands, 1923, and lo, 1931, made lights the unit of measure for how eager institutions are to downplay anomalies that won't perish on command. He delighted in the letters column of the observatory where Royal Navy officers described rotating sea lights off Aden, 1892, and he poked the quarterly journal of the Royal Meteorological Society whenever a correspondent invoked marsh gas, with the same confidence a schoolboy invokes dragons. He understood the sociology: call the thing a miracle and you get the church, call it a fraud and you get a career. Call it unknown, and the printer yawns. A century on, we can keep his derision but retire his helplessness. He lacked cheap grating film, we can buy a box. He lacked GPS, we get nanoseconds for rent. He lacked an air traffic feed, we get hex IDs, squawk codes, and climb rates in a console window. He lacked dual pol radar, we get ZDR and HV plots that tell raindrops from chaff and bats. He lacked field mills, we screw one to a post. That's not triumphalism, it's an ethics upgrade. The ethics piece matters because the places where these files live are not laboratories, they're towns. Alpine, Texas has 6,000 to 7,000 people and a sheriff who doesn't want the overlook to turn into a litigious campground every clear night. Valleys in Trindelag where Hessdalen lives are farms with neighbors. Their owners should not wake to find a van of strangers running extension cords into a hayfield at 2 o'clock in January. The way to eliminate friction is a written compact tied to a school. A high school physics teacher with a key to a container that holds the instruments, a community meeting that pre-commits where cameras point and where they don't, a posted roster of nights when volunteers will be out, a chain of custody simple enough that a county clerk can read it. The oversight isn't cosmetic, it builds trust so that the spectacular night isn't followed by a spectacular meeting about property rights. It also makes the data usable in court if, say, a pilot files a near-miss report that later turns out to be a sky lantern. Now tilt the camera 100 years forward, because this subject gets interesting only when you assume better toys. By 2125, low-light single-photon avalanche diode, SPAD, arrays at megapixel scales will be cheap enough to litter on ridgetops, hyperspectral video. Dozens of narrow bands logged at 60 to 120 frames per second, will treat every dot as a fingerprint. Time-synchronized baselines will be longer. Because the communities that learned how to triangulate meteors in the 2020s will have repurposed their all-sky rays for anything luminous. A mesh of GNSS-disciplined microbarographs and VLF receivers, originally seeded to validate ionospheric models and hear microbarometers from oceans, will sit in every National Weather Service's archive and let you reconstruct inversion ducts and field spikes across a state with one API call. Air traffic transparency will be almost total. Uncrewed vehicles will broadcast their trajectories and intentions as a license to exist near towns, and a public ledger will make anonymized positional data queryable with lat-LON boxes and time windows so citizens can say, everything in the air out to 200 kilometers at 21 hours 14 minutes and 32 seconds, please, without a lawyer. The part that looks like science fiction, dense ground networks that capture the electric field at kilohertz rates, and SPAD arrays that pull a sodium line out of a flicker too dim for human eyes, will just be consumer leftovers from astronomy and telecoms. Add machine learning models trained not on mystery, but on physics, priors that know how a sodium flare varies with altitude, how a headlight spectrum moves with distance and humidity, how a plasma continuum cools, and you will have a classification pipeline that runs in seconds. The residue that survives will be an honest residue. Does that future ruin the romance? Only if your romance requires ignorance. The nights that will still make sense to write about. The Hessdalen nights with a narrowband shoulder no headlight owns. The Marfa nights when inversion ducts are absent and a steady ember a kilometer off the ground drifts at 3 to 5 meters per second crosswind without identifiable parents. The post-seismic evenings in a rift valley when glows roll along a fault trace you can map, will be far more interesting with temperature curves, spectra, and tracks than they are with adjectives and conviction. If the explanation is dusty plasmas shaped by the valley's weak field, or piezoelectric air that somebody's PhD turned into a laboratory spectrum 2 decades earlier, the valley earns a chapter in a physics text as well as a brochure. If the explanation is a false positive slapped silly by a cinch check against ADSB, you've retired a rumor without slandering eyes and you've done it with grace. Even in the edge cases where you find only human artifacts, lanterns, hobby drones, flares, you've catalogued the kinds of mischief that teach municipal policy what to ban near overlooks at certain hours. There is dignity in solving the solvable. The only trap worth naming at the end is the one Fort built for himself and then mocked, selection bias with a brass handle. He loved collections of exceptions more than he loved denominators. He loved damned data because it let his temperament play. We can afford both the heap and the fraction. When you integrate the automatic station logs in Hessdalen across 5 winters and count the true positive luminous events per 1,000 hours, when you align Marfa overlook logs with radiosonde-derived inversion strength and show a clean peak at nights with a shallow, strong surface inversion, when you cross-tab Brown Mountain reports with known train schedules for 1911 to 1930 and watch the bars live where the timetable lives, you honor Fort's archive while freeing yourself from his romance. You also inoculate your town against the press office that wants a ghost because hotel tax receipts need a narrative. So, how to end a journey that began with a Bronx index card and winds up with hyperspectral video? With a field night, not a flourish. Picture a winter evening at 62.8 degrees north. It's minus 10 degrees Celsius, the aurora has decided to write its own diary, and your station in a red shipping container is humming. The all-sky camera has been sulking at clouds since dinner. At 22:14 the field mill twitches, the microbarograph catches a soft step, and both bore-sighted cameras pick up a bead 3 degrees above the ridge, azimuth 199 degrees, drifting right to left at maybe 3 meters per second. The slit camera paints a stubby spectrum on the sensor that your phone turns into a plot, broad hump at 650 to 800 nanometers, no sodium, a hint of green oxygen. The ADSB log is boring. The rail schedule says nothing will enter the gorge until 2340, the drone ID table is empty, the inversion profile is weak. You do not post adjectives, you post frames, spectra, and times. Later, on a couch, you plot it and discover the track sits over a boggy patch where your resistivity transect showed a lens of water and a buried boulder with a piezoelectric heart. You call a mineralogist. A month later you tell the town what you found, and you tell them with the same grin you brought to the overlook. In Texas in August, under a different sky at 30 degrees north, you run the same drill, retire 5 nights of ducted headlights with delightful brutality, and keep 2 frames because the spectrum is interesting. In North Carolina in October, with leaves doing their fatal chemistry, you let the trains perform their physics demonstration at 2019, log it with satisfaction, and stay anyway because that is what curiosity does. Fort's name deserves to be here because he taught the culture to keep files on its own disobediences. He would have harassed you for your priors, mocked your graphs, and then demanded copies because he loved paper even when he did not love your conclusions. He once joked that we are property, a provocation designed to immunize readers against certainty. The line that matters more now is the one implied by the box of cards he kept, that wonder, to endure, must pay rent in dates, latitudes, and the devices that make memory behave. The lights, whether train, plasma, inversion, or something the next decade gives a better noun, will keep turning up when air calls and ground sings. Our job is to meet them not with a spotlight and a sermon but with a clock, a slit, and a notebook, and to carry the humor that keeps a community from mistaking measurement for contempt. The future of anomalistics is not a television pitch, it is a field kit and a public archive, a valley with neighbors that knows exactly where the cameras point and why. Close the car door, bring a thermos, label your files. When the glow lifts over the ridge and begins to slide in defiance of your boredom, be ready to do something Fort could not. Pin it to the map and to a spectrum until the only thing left unresolved is how much wonder you can keep after the numbers sit down and look you in the eye. That, at last, is an ending that can carry a century.